It would explode and decimate all of New York City, parts of Connecticut, and New Jersey. This is potentially one of the best mysteries in our material science. Betelgeuse, a heavenly marvel gracing the night sky, is a well-known red, very Goliath beast. It got comfortable in the Orion star gathering, amazing stargazers for a long time. Later, invigorates from prominent physicist Mito Kaku have raised concerns, proposing that creepy crawly juice could have finally exploded. How this impact reshaped our perception of heavenly life cycles and the powers shaping our universe is a question of inconceivable significance. What ideas does it hold for us? Stay blocked to figure out. Imagine checking out the night sky and perceiving a breathtaking star in the Orion Great Body. Bug Squeeze, in any case called Alpha Orionis, is a gigantic great body at about 5 hours 30 minutes right rising and 0 declination. It gathers its name from the Arabic word bat al-ra, meaning the beast's shoulder. In 16003, cosmologist Johann Bayer gave the star its phenomenal name, Alpha Orionis, inferring its status as the most magnificent star in the Orion star gathering. Unusually, despite being seen as the most amazing in Orion, Bug Juju holds its name proudly. Betelgeuse is a monster star with a mass on numerous occasions more essential than our Sun, making it a Goliath, diverged from our planetary gathering. To put it in context, on the remote possibility that the Sun were a little marble, Betelgeuse would be a gigantic ball. Betelgeuse's distance has been challenging to measure, with checks setting it someplace in the scope of 5,600 light-years from our Sun, an enormous distance in cosmology. In terms of magnificence, creepy crawly juice shimmers brilliantly with a truly magnificent rating of around 6. Harvard School investigator Morgan McLeod took note that Betelgeuse's closeness and size make it one of a handful of the stars scientists can closely assess using telescopes on Earth and in space. Telescope pictures reveal Betelgeuse's unique components, showing a surface evident from our Sun's smooth appearance. Instead of a uniform circle of extraordinarily hot plasma, Betelgeuse appears as a grouping of unbalanced, foaming gas pockets, some essentially indistinguishable in size to little stars. Huge ejections of hot material emerge from Betelgeuse's center to the surface, looking like cosmic spring cleaning. One such shell is immense. Direct that, going at the speed of light, it would require 75 years to cross. This cycle, known as surface mass release, heaves materials from Betelgeuse's outer layers, like the Sun's coronal mass releases, not enduring differing internal plans and cycles. Betelgeuse, at a simple 10 million years old, is astoundingly energetic, stood out from our Sun. Despite its childhood, creepy crawly juice has already exhausted the hydrogen fuel in its middle, entering the later periods of its presence as it advances into the red, very monster stage. During this stage, Betelgeuse utilizes helium to make carbon through fusion processes, showing a quick, groundbreaking outing energized by its huge early-on mass. Upon entering the world, scientists suggest Betelgeuse started its pretentious journey as a blue-white type star, belonging to the most significant arrangement of hydrogen-consuming fundamental arrangement stars in the area of stars. Size directly associates with wonder and extreme force. Larger stars, like Betelgeuse, shine all the more brilliantly and consume all the more fervently, yet this also leads to faster hydrogen usage and an earlier movement to the red monster stage. Betelgeuse's surface compasses amazing temperatures of up to 89,500 degrees Fahrenheit, a sharp contrast to our Sun's 10,000 degrees Fahrenheit. As Betelgeuse consumed its hydrogen and started interlacing helium, its outer layer extended significantly, making it very possibly one of the biggest stars we know, expanding in excess of 700 million miles in diameter. At this point, creepy crawly juice's surface temperature is around 5,800 degrees Fahrenheit cooler than the Sun, yet it overwhelms the Sun by an essential 7,500 to 10,000 times. In 1836, stargazer John Herschel took note of changes in Betelgeuse's splendor, prompting its order as a semi-standard variable star with irregular changes and intermittent erratic varieties, often following a multi-day cycle. In 2019, Betelgeuse showed an eccentricity, going astray from its normal way of behaving. Betelgeuse's late lead collected attention because of its rare changes. For the most part, its brilliance faltered following a steady 400-day design, illuminating to an extent of 1.3 and then decreasing to around 2.8. These instabilities were connected with the outside layer, called the photosphere, which sends most of the star's light and intensity through convective development. In the photosphere, where intensity moves from within to the surface through gases, it causes variations in quality over time. During the fall of 2019, Betelgeuse experienced a significant decrease in brightness by around 60%, marking a deviation from its normal pattern. The reason was a massive release of material forming a large dust cloud that obscured our view. Although the dust cloud has since dispersed, Betelgeuse hasn't fully returned to its previous state, and its 400-day luminosity cycle has condensed to just 200 days. Betelgeuse's unusual behavior has sparked discussions about the potential for an imminent supernova explosion. In a supernova, as the star consumes its remaining fuel, its core collapses, leading to a black hole, while simultaneously launching external layers at speeds of up to 25,000 kilometers per second. If Betelgeuse were to undergo a supernova, it would be a dazzling display visible for months, similar to the full moon, due to its proximity of just 650 light-years. While supernovae are common, they are often too far away to be seen without powerful telescopes, making Betelgeuse's potential supernova a remarkable event for night sky observers. As stars evolve, their cores accumulate iron, eventually triggering a supernova. The most recent observable supernova, SN 1987A, occurred in 1987, around 168,000 light-years away. This event was visible to the naked eye and provided significant insights into stellar development. The last recorded supernova before that, observed by Johannes Kepler in 1604, outshone all other stars in the sky, even during the day, but had no significant impact on Earth due to its great distance. Betelgeuse, a star at the center of attention, is expected to go through a supernova. Miguel Monteros, a Betelgeuse expert, predicts that its brightness could match that of the full moon when the supernova moment occurs. Imagine an enthralling 2-month period where, on a clear night in a dark city, you could read a book by the glow of Betelgeuse's supernova. In 2021, Betelgeuse experienced another dimming event similar to the 2019 one, with a 60% decrease in brightness due to the presence of a cloud in the star's wind. This cloud obscured part of the star, causing a missing southern hemisphere in images. After this dimming event, Betelgeuse unexpectedly increased in brightness by around 50%. The reason for the surge remains unclear, sparking theories among astronomers. Betelgeuse, now 15 to 20 times the size of the Sun, falls into the category of stars expected to undergo a supernova. Astronomers generally propose that Betelgeuse could explode within the next 100,000 years. However, a study by Hayuki Cio and colleagues from Tohoku University suggests it could be in a more advanced stage, closer to exploding. There are varying opinions on the validity of this conclusion. Cio's team bases their statement on Betelgeuse's pulsating behavior, which is consistently expanding and contracting with varying hints. While they do not predict an imminent explosion, they suggest it could happen within the next 1,000 years, testing the longer timescales previously considered. The uncertainty surrounding Betelgeuse's timeline has captured the interest of astronomers, though some researchers argue that stars like Betelgeuse can last for more than 10 million years, an incredibly short time span for astronomers but surprisingly long for those outside the galactic neighborhood. As they search for clues about whether the bright star could become a supernova, astronomers note changes in the star's color in older images. People describe the star's color as similar to Saturn's yellowish hue, not Mars's reddish color. This raises the question, has the star's color changed? If so, it could indicate rapid development, suggesting that a supernova could occur sooner than expected. This color shift offers a clue about the star's changes, supporting researchers in interpreting cosmic events. Whether Betelgeuse undergoes this explosion on time or not, it's bound to provide a radiant show. Humanity will have a front-row view to witness the confirmation of extraordinary astronomical phenomena. What could happen if Betelgeuse went supernova? The possibility of a supernova appearing in our sky has captivated people's imaginations. New simulations help astronomers understand what we could see when Betelgeuse eventually explodes. Though it is anticipated to happen within the next 100,000 years, uncertainty remains. Betelgeuse is around 500 light-years away, and recent research suggests that a significant star must be within about 150 light-years to cause distinguishable effects. Around quite a while back, an occasion of this nature might have had an impact on marine life after the Permian extinction. If a cosmic explosion happened in our district, nearer than 30 light-years, things could get dubious. Despite the fact that Betelgeuse's cosmic explosion isn't expected to compromise life on Earth, there may still be some air impacts. The blast would produce a flood of ultraviolet radiation, possibly leading to a short decrease in the ozone layer. However, research shows any resulting ozone depletion would almost certainly be minor and brief, with limited environmental consequences. Right after the blast, we would recognize weightless particles called neutrinos, which are innocuous to us. The star would immediately become brighter, reaching a radiance like the full moon. Within only weeks, Betelgeuse's splendor would then wane. Over time, it would grace our night skies for around half a year to a whole year. As night slips, it would continue to be a noticeable display for another 1 to 2 years before saying goodbye to us for good. Unfortunately, Orion would lose its red sparkle, a gleam carved into memory. As for the risk to mankind, supernovae produce solid particles known as cosmic rays, which can infiltrate Earth's magnetic shield. However, aside from the closest supernovae, the amounts would be generally minor compared to other radiation we experience. The cosmic explosion's dazzling finale wouldn't just entrance us, it would also create radioactive iron, a massive mark found in Earth's ocean floor and even gracing the moon. This iron, brought into existence by a cosmic explosion that occurred 2 to 3 million years ago, was a mere 300 light-years from us. Fortunately, its proximity posed no significant risk to life on Earth. Have no fear, such a nearby cosmic blast is an unprecedented case, possibly happening only once in a billion years. As theorized about the potential appearance of a Betelgeuse cosmic explosion, Space Master Andy Howell from the University of California was not happy with basic back-of-the-envelope estimates. He sought more precision, enrolling the help of 2 ex-graduate students, Jared Goldberg and Evan Woods. Their complex simulations clearly depict the star's epic finale, recognizing uncertainties while using insights from observations of supernova SN 1987A, the closest recorded instance of a star's destructive end in recent centuries. These cosmologists concluded that life on Earth would remain unscathed. However, the cosmic scene will not be ignored. Goldberg and Wood's discoveries show that when Betelgeuse lights up, its brightness will resemble the gentle glow of a half-moon, shining about 6 times fainter than the splendor of a full moon. This entrancing iridescence is projected to grace the skies for over 90 days. Late investigations demonstrate that Betelgeuse is around 724 light-years from us, safely outside the typical risk zone. Nevertheless, the cosmic explosion could have captivating ramifications for Earth. Howell highlights that many animals rely upon the moon for navigation and may be confused by extra-bright objects. Cosmologists themselves would face challenges, as the extraordinary brilliance would surpass the capabilities of telescopes and space observatories. Telescopes would need to adjust to capture the subtler glow. Experts assure the public that there will be more than adequate advance notice if Betelgeuse goes supernova during our lifetimes. Earth's instruments would detect signals like neutrinos or gravitational waves created by the impact, giving us a heads-up as much as a day before the event. Although this event is unlikely to occur for another 100,000 years, Betelgeuse will eventually become a cosmic explosion. The fallout depends on the materials that remain after the great finale. We expect Betelgeuse's eventual cosmic explosion, and as specialists continue to refine their forecasts and improve their understanding of such heavenly phenomena, observations of similar stars in different stages of their development provide vital information for modeling the life cycles and possible violent ends of massive stars. This data helps cosmologists evaluate the frequency and impact of supernovae within our universe, contributing to our broader understanding of cosmic events and their implications for both nearby and distant celestial bodies. The study of Betelgeuse and other supergiants also aids in calibrating astronomical distance scales. Accurate measurements of such stars' brightness and behavior help refine the methods used to determine distances to faraway galaxies, thus improving our overall mapping of the universe. Moreover, supernovae act as valuable tests for understanding the synthesis and distribution of heavy elements like iron and nickel throughout the universe. These elements play a critical role in the development of planets and life as we know it. In the meantime, space observatories are closely monitoring Betelgeuse and similar stars, using cutting-edge technology to detect any signs of impending change. These efforts ensure that we are prepared to observe and study one of the most dramatic events in the universe's life cycle, enhancing our knowledge of the dynamic processes that shape the cosmos.